Alrighty guys, welcome to another fun-filled lesson on conics. Today we're talking about hyperbolas. So we're going to graph them and we're going to write their equations today. So this is what a hyperbola looks like. It kind of looks like two parabolas, kind of. But they have these diagonal asymptotes. All right. Now the center of the graph will be this point here. And once again, that's the H and the K, so that's good news. Nothing too new there. Same thing over here. All right. Now you may notice something, though, different about these two graphs. You may notice that this one, the curves are on the left and right, whereas this one, they're on the top and the bottom. And compare these two equations up here, and you'll see why. Whenever the x comes first, followed by the y, or I guess maybe another way of saying it is the negative is in front of the y, because technically I could put this in the front. If the negative is in front of the y, then your curves will be on the left and right. But if your negative is in front of the x, your curves will be on the top and the bottom of the shape here. Okay? So that is a hyperbola. That's about as deep as we're going to go into it. There's some other things we could talk about with it, but I think the most important thing for you guys in this class is just to know how to graph them and to know what they are. And so that's what we're going to be focusing on. Now, whenever you're graphing these things, after you plot your point, you're going to do kind of like the same thing we did with ellipses, where you take the square root of this number under the x, and that tells you how far to go to the left and right. And then you take the square root of this thing, and that tells you how far to go up and down. Okay, so we could label these B and A. And what you're going to do is you're going to draw a box. Okay, not a circle, but a box. And the diagonals will go through the corners of the box there. So the reason that we draw the box is so that we can draw the diagonals so that we know where to put the little curves. Okay. And the curves will touch the sides of the box. Okay, so the square root of A is going to be the vertical value this time because it's underneath of the y. And the square root of B will be the horizontal value because it's under the x. And once again, we're just going to be drawing a box. And the diagonals are the asymptotes that help us know where to put the curves. All right, so let's go ahead and get down to business here, and we'll practice graphing some of these things. So let's go ahead and graph this one here. So step one is going to be to find the center. The center is, once again, the number that's being subtracted from x, which in this case is not there, so it's 0, and the number being subtracted from y, which is 1. Okay, so now we move on to step two. The horizontal length in the vertical length is what we want to find next. So the horizontal won't be the one underneath of the x, but you are going to take the square root of it, so it's going to be 5. And then you're going to want to find the vertical length, which will be the number underneath of the y. You want to take the square root of that. And this is not a nice number, so we're going to go ahead and just use a calculator and estimate it. And I get about 3.9. Now that's pretty much 4, but we could keep it as 3.9. All right, step 3. Step 3 is going to be draw the center and then use those horizontal and vertical lengths to sketch a box. So here we go. My center is 0, 1, which will be right there. My horizontal length is 5, so I'm going to go out 5 to the right and put a dot. And I'm going to go out 5 to the left and put another dot in line with the center there. And then for my vertical length, I'm going to go up and down 3.9. Now 3.9 is pretty much 4, so I'll put my dot there, maybe just a little bit barely below 4, but honestly it doesn't really matter. So we have that. Now when we were doing ellipses, we connected that with a circle or a curve, right? But this time we're going to connect it with a box. Like so. Okay. Step 4 is to draw the asymptotes. And to draw the asymptotes, we're going to draw diagonals through our box, and they have to go outside the box, just like so. All right, step 5. Step 5 is to decide where the curves go. So are we going to draw the curves on the top and bottom, or are we going to draw them on the left and right? Well, in case you forgot, this one had the x squared first, and the minus, and then y minus 1 was second. So when the negative is in front of the y squared, this is one where you're going to draw the curves on the left and right. Now here's how we draw the curves. The vertex is on the box, and then after that the curves go up to the asymptotes on both sides like that. So there's that. Same thing over here, up to the asymptote, up to the asymptote. Now just so you guys know, all the stuff in black here is just the guiding lines we use to get our curve. The actual curve is these red lines. So the red lines are the hyperbola that we were trying to graph. So there's our 5-step process for graphing. You can find the center, find the horizontal and vertical lengths, draw the center and use those horizontal and vertical lengths to sketch a box, draw the asymptotes through the diagonals, decide where the curves go. All right, let's go ahead and have another example here. All right, so this time I'm not going to write out the steps, but I did want to do one more example before I cut you guys loose and let you practice one. So step 1 is I'm not going to write the words for the steps, but I am going to show my works for each step. So step 1 is to find the center. The center is the number that you're subtracting from x, which is 0, and the number which you're subtracting from y, which is also 0. Be careful here, because since the y comes first, you might be tempted to put the y number here, but whenever you're writing a point, the x comes first, no matter what order they're in over here. Right? Next, so the next thing I'm going to do is I'm going to find my horizontal length and my vertical lengths. So the horizontal length is the square root of the number that's underneath of the x, which is 2, and the square root of the number underneath of the y, which is 5. All right, now I'm ready to start graphing. So my center is 0, 0. I'm going to go up and down 5 because that's my vertical length, and left and right 2 because that's my horizontal length, and then I'm going to draw a box at those distances. Okay. The next thing we do is we draw a diagonal through the corners of our box, and those are the asymptotes for our graph. The last thing that we're going to do is we're going to decide where do the curves go. So since the negative is in front of the x squared, that means the curves go on the top and bottom. So the vertex will be on the box, and after that you hug the curve up against the asymptote like so. And that's that one. Okay, so let's go ahead and have you guys try a couple of these. Go ahead and pause the video. Give this one a try. When you unpause it, you'll see the solutions. All right, guys, and there's the answers. One weird thing over here on the second one, if there's no number underneath of the x minus 3, that means it's 1. So you'll notice that the horizontal length was only 1 space in length. All right, so let's go ahead and move on to our next part of the lesson for the day. And that's identifying what these are. So we've talked about 4 types of conics, and I want you guys to be able to notice what they are. Now on the notes, I'd like you to add some extra notes that I'm about ready to write here. What the notes I'm going to write are what's unique about each one of these things. Okay, so for a parabola, the thing that makes it unique is that there is only one variable squared. Only one variable is being squared. So over here you guys can see the x is being squared, but not the y. Now just so you guys know, you may recall that you could also have this thing written like this, but it doesn't really matter which one it is, because in either case you only have one variable being squared. Okay. Now what makes a circle a circle? That one's a little bit strange. You'll notice that circles and ellipses are pretty similar. And in fact, if I were to divide both sides by an r squared, this part you don't need to write necessarily, but if I were to divide by an r squared, let me make a little adjustment here, then this side over here would become 1. And so basically at that point, there's almost no difference between an ellipse and a circle. So how can we tell them apart? Well, in this case, they have different numbers under the squares. So ellipses have two different numbers. The x will have one number, the y will have another number. Whereas with circles, they'll have the same number. Okay, so that might be one way to think about it. Or another way to memorize the difference is just to see that ellipses have these little denominators, whereas r's or circles may not. They just may equal some number. Okay, so there's a couple ways to tell the difference between them. But something else that I would point out is that this thing has a plus sign. So here's what we should write, has a plus. Okay, that's important because hyperbolas don't have a plus, they have a minus, and that's what makes them special. But ellipses also have a plus. Okay, so just because it has a plus, well, we know that it's either a circle or an ellipse, but how can we tell the difference between them? Ellipses have two different denominators, or we'll say coefficients, and you'll see why when we get to the next page. Whereas circles have either one coefficient, or actually we should just say the same coefficient, or you could say denominator, or you could just say it equals something. Okay, whereas these guys equal 1, a circle could be equal to something else. Now the last thing that makes hyperbolas special is that they have a minus. That's what makes them special. Okay, so we've learned 4 types of conics: parabolas, circles, ellipses, and hyperbolas. Parabolas, what makes them unique is they have only one squared variable. Hyperbolas are special because they have a minus in between their x's and y's. Circles and ellipses have something in common. They both have a plus in between their x's and y's. But what makes them different is that ellipses have 2 different radii, or coefficients or denominators, whereas circles have only one radius, which can be over here, or if you put it underneath, it still looks like the same radius either way. So that's how you can tell those 4 things apart. Now, this is what they look like in the transformational form, but we've been doing a lot of problems where they're not in transformational form and we make them that way. But you can actually tell what they are without having them in transformational form. So I want you guys to, let's go through this, and what we're going to do is before we transform them, we're going to decide what type of conic these are, okay? So let's take a look. This one has 2 squares, so it's not a parabola. Parabolas have only one squared term, okay? Also, the squares have a negative between them. One of the squares has a minus. Well, there's only one conic that has a minus, and that's the hyperbola. So even though this is not in transformational form, we can still see what it is. Let's take a look at number 2. Number 2 has 2 squares, so it's not a parabola. It has a plus in between it, so that means it's either a circle or an ellipse. But notice that their coefficients are different. That means it's an ellipse. If they had the same coefficient, then that would be a circle. But since they have different coefficients, that's an ellipse. Let's take a look at number 3. This one has only one squared term. That's a parabola. How about the last one? We have an x squared and a y squared, so it's not a parabola. It has a plus, so it's a circle or an ellipse. And the coefficients are the same, therefore it is a circle. Okay? So that's how you can decide which is which. Now the directions tell us to do a little bit more than that. It says, identify which conic below is a parabola, circle, ellipse, and hyperbola. But then it says, then write the hyperbola in standard form. And actually what I meant to put there was transformational form. So I'm going to erase that, and you guys might want to change that on your notes too. Transformational form. Okay, so we've already decided that the one on top here is the hyperbola, and we're going to change that into the proper form. So how do we do that? Well, pretty much the same way we did circles and ellipses. So let's begin. So step 1 is we want to group the x's and the y's. So I'm going to put 4x squared plus 16x in parentheses. And the y squared in this case is all by itself, but usually it'll have something there with it. And there's no constant to move to the other side this time. Then what do? Well, we factor out the leading coefficient. So I'm going to take a 4 out of here. This one doesn't have a leading coefficient, so we're just going to leave it alone. I think I'll rewrite that a little bit differently, though. I'm going to put the square outside the parentheses. All right. Now what do? Well, now we complete the square. This one doesn't need to be done because it's just a y squared. It's already a perfect square. So we'll leave that one alone. But for this one here, we're going to take half of this number and square it and put our answer there, which is 4. And then we're going to fix the balance by multiplying these together and putting the result over here. So that's 16. Next, we're going to factor. If I factor this, I end up with x plus 2 squared. The last step I'm going to do is I'm going to divide everything by the 16 so it's equal to 1. So if I do that, I have 4x plus 2 squared over 16 minus y squared over 16 equals 1. And then finally, we could take this 4 and divide it into the bottom, and we get x plus 2 squared over 4 minus y squared over 16 equals 1. And there's our final answer there. So the steps are very similar to the steps that we would follow for the ellipses. I think I'll do one more example with you guys just to kind of drill it home. So what I didn't like about that last example was that there was just a y squared. And so I want you guys to see how to handle it when there's more than that. All right, so we'll do this one. Now you guys may be tempted to just skip this because we've already done one, but I would not, because you're going to see there's a couple things that are different here. So let's go ahead and do one more before I set you loose on a student practice. So once again, we start by grouping the x's and the y's. So I'm going to put my 4y squared here with my 8y. And then I'm going to take this 9x squared and put it with the 36. Now I'm going to do something a little bit weird here. I'm going to put the negative in the parentheses with it and put a plus in the middle. Now that seems like a weird thing to do, but that's actually pretty important. So you might want to star that step. That's a strange thing to do, but we didn't have to do last time because there was only one variable, but you'll see why we do it in a minute. Equals 68. Now here's why we do that. Because the next step is to factor out the leading coefficient. So I'm going to divide out a 4 here. Now here, I have to divide out a negative 9. If I had put the negative out here, you guys might have thought, oh, well, I only need to take out a 9. But that's not true. You actually need to take out a negative 9. So that's why it's important that you put that negative with the x squared in parentheses and just put a plus in between them as a placeholder. But now I'm going to go ahead and take out that 9 like so, the negative 9, which will leave me with x squared minus 4x, because remember, we are dividing by a negative here. So that's the biggest thing I want you guys to see. The rest of it really isn't too different, but let's go ahead and see what shakes loose with the rest of the problem here. So now is the completing the square step. At this point, since we have these, I'm just going to change it now to a minus 9. So let's complete the square. So half of 2 squared is 1. And 4 times 1 is 4. So I need to add a 4 to the other side. Next, half of 4 is negative 2. Squared is 4. So we have plus 4 here. And then we do negative 9 times 4, which is negative 36. Next, we factor and combine our like terms. And that one's going to take some mathing, so let me get my calculator here. 36. Next step is to divide both sides by 36 and then simplify. So here, I'm going to divide 4 into the bottom, and I get y plus 1 squared over 9. Minus, here I'm going to divide the 9 into the 36, and I'm going to get 4. And over here we have 1. And now we're done. That's transformational form. So there it is. So the main step to pay attention to is this one up here, where whenever you group the variables together, the one that's negative, make sure you include that negative in the parentheses, and make sure that's what you factor out up in the next step. Okay, so there it is. So I'm going to go ahead and set you guys loose on one of these here. So what I'd like you guys to do here is, first of all, label each one of these as a parabola, a hyperbola, a circle, or an ellipse. And then I would like you to change the hyperbola into transformational form. So 2 things. Identify them and then transform the hyperbola. Okay? When you unpause the video, I'll have everything all labeled out for you. Alright guys, so there it is. Number 1 was a parabola, number 2 was the hyperbola, number 3 was the circle, and number 4 was the ellipse. Number 1 was a parabola because there was only one variable being squared. Number 2 was the ellipse because the x squared, there's an x squared and a y squared, and there's a negative between them. Number 3 was a circle because there's an x squared and a y squared with a plus between them, and they have the same coefficients. Whereas number 4 is the ellipse because we have an x squared, a y squared with a plus, but they have different coefficients. Okay, so we decided that we were going to transform the hyperbola, and so here's the steps. I'll let you guys go ahead and study that, but that would be your final answer there. I think the only thing that maybe might have been a little confusing is that one, once again, that weird step where I said make sure you put the negative in the parentheses, and then when you do have to factor out a -1, which means this -4 will become a this +4 will become a -4 when you divide out a -1. So you might have had some issues here with the first 2 steps, if anything, but the rest of it was all pretty standard after that. So that does it for our lesson today. Hopefully it was helpful. We'll see you guys in class to practice this stuff some more. Till then, have a good one. Bye-bye.